Live from the NBC News radio broadcasting studios of KCAA, 1050 AM, 102.3 FM, and 106.5 FM, located in beautiful downtown sunny California. Welcome to the Water Zone Show. I hope everybody's having a great afternoon. My name is Rob Starr. I'm the host for today. Mr. Mike Barron is off tonight, but I know he's listening carefully by his radio. I hope so. And today is our special training day that we do for the Irrigation Association, and we do this once a quarter. We bring in an industry expert to go through a specific topic, and those of you who are listening can hear the presentation, but we also advise you to go to your computer at www.kcaaradio.com, and you can actually see us live because we're broadcasting in vivid color, and we'll give you a little wave out there to everybody. Today we have a guest presenter. His name is Tom Glazner, and he's with the Ewing company, Ewing Irrigation, and he's one of the gentlemen who does education for them. And Tom, welcome to the show.
Well, thank you very much. Glad to be here.
Can you give our listeners a little history about yourself and what you do and where you hail from?
Sure. Well, right now I hail from Portland, Oregon. I work for the Ewing Irrigation Training Team. We have Ewing Education Services, which does training for our contractors and our municipalities across the country. And I've been working for Ewing Irrigation for the last 11 and a half years.
Wow.
And been in the industry for 25.
Wow, excellent. I know the people like Borneman and other people we've worked with before on some other projects, and I got to commend your company, because Ewing, even going into the stores, your people are trained. You ask them a question, they know what they're talking about. I love it. It's good. So anybody who needs any irrigation equipment and products, go to your nearest Ewing store. They're great people, great service, and they pretty much have everything you ever need.
Glad to hear that.
Yeah. And that's the truth. That's the truth. I shop only two different companies, but you're one of them, and I'm very happy about that. I've always supported that. Anyway, today you're going to make a presentation about...
Today we're going to talk about the irrigation system inventory.
Okay. And just for the listeners, again, if you go to www.kcaaradio.com, you'll be able to see the presentation live. And at the end of the presentation, what you do is you send an email to the Irrigation Association, and I'm going to give you a special code, not now, towards the end, because we want to make sure you listen to this, and you get some continuing education units. And we do this, as I said, on a quarterly basis. It's something that we partnered with the Irrigation Association, and we think it's a good thing for both the professionals and even the homeowners, because you learn a lot of stuff. Most homeowners don't know anything. They go into the big box stores, and yet they ask somebody in the store who doesn't know what you need, or no less than what you know, and you wind up buying the wrong parts, and it gets to be a problem. Like somebody comes in, they want to buy a valve. Well, each valve is a little different. The spacing's a little different. And, you don't bring a sample, nobody knows what you're talking about. If you don't even know the model number, you get in trouble. So those are the things that's important. And now we got an expert. So, Tom, I'll give it to you.
Fantastic. So we're going to talk about the irrigation system inventory today. The whole purpose of this, the reason this came up in the first place was...
No, go ahead.
Well, the reason this came up in the first place was we would find that we have a lot of contractors, even those who are not necessarily irrigation contractors, who didn't know what they had in the field when they were trying to go back and troubleshoot. Perhaps they would go back multiple times, and every day would be like Groundhog Day. So we started off by, we'll look here first. We have different landscapes that we're all in. So here's one down in Phoenix, right near our home office. This is the Cesar Chavez National Monument outside Keene near Bakersfield. Another shot of that place. And so we have different types of landscapes featuring different types of plant material. Salvador Dali's here just to show you the Salvador Dali Museum down in St. Petersburg, Florida, and featuring Salvador Dali's mustache. But there's lots of different types of plant material that are being irrigated here. And this is a typical yard up in Portland, Oregon. And so here, as opposed to all the tropical stuff we were seeing down with the Dali Museum, here we have a bed of tulips as well as understory plants. So our irrigation needs are going to be different here. But notice none of these landscapes are featuring the irrigation. They're featuring the plant material.
Because it rains a lot in Portland.
Well, it does rain a lot in Portland, but it's seasonal too, and so we have a drought period as well as we do it down here in California. And then this one is in Bentonville, Arkansas. This is one of Frank Lloyd Wright's Usonian homes that was brought out of New Jersey. And this site was created at the Crystal Bridges Museum of American Art, so that house could then be rebuilt on site and could live on. So that landscape there is working as a situation for that house. But we don't look at the irrigation. We're looking at what the irrigation serves. So whether it be the desert, whether it be a national monument, whether it be a strange museum in a remote locale, whether it be a suburban house in Portland, or a featured home in a museum area, all of these things are being served by irrigation, but the irrigation isn't out there saying, hello, here I am, come and find me. So that's why we have the irrigation inventory. And so we'll inventory for a number of reasons. First, the simplest one is just simply to understand what makes up the current system. What's there? What do I have? The next thing is, what do I have that is working and what's not working? I need to identify, of those things that are not working, what are urgent repairs or modifications that need immediate attention? And then what are things that could be upgraded and improved, but that are important, that will make the system more efficient and more effective, but are not immediately needed to make it so that the system will work? Also, I'm gathering information that I can then put into a system for future management. So if I manage systems now, this is something that I should already be doing. But if I'm thinking about getting into irrigation management as well as any other landscape management I'm doing, then this is where I can gather up all the information about the system components so that way I can figure out how I'm going to plan for the future.
Tom, just a quick
Yes,
question.
sir.
Do you find, let's move from the professionals for a second just to the homeowners, and I didn't mean to interrupt.
Oh, please.
But do you find that most problems that people have at their homes is because they don't take care of their equipment?
Maintenance is, regardless of whether it's at their homes or whether it's in our professional environments, maintenance is the key killer. Because if it's in a professional environment, usually that is the part that gets hit in the budget first. For homeowners, many times they have no idea about how to maintain the product, or we live in a set it and forget it environment, and Ron Popeil helped us with that. So my professional put it in the ground. Isn't it always going to work? Just like your car always works. If you don't maintain your vehicle, same thing, right? And so so if we're gathering information for the future management, well, then we're going to have plans. We're going to have plans not only for improvement, we're also going to have plans for maintenance. Once we know what we have, then we have an opportunity to figure out how we're going to deal with it. Also, future contracts, if we're going to develop any kind of performance contracts, whether we're going to save so much water by virtue of our improvements, then having accurate information on what exists is going to be a starting point for us. Performance estimates. What's the system right now capable of doing? How can I know how I'm going to possibly change things unless I know what the system is able to do right now? And then also for billing. I come to a site and I look and see what the pressures are on a particular system. Say, for example, I'm looking at a fixed spray zone, and we'll go into the different types of irrigation heads as we go through this. But let's say that I'm taking the pressure readings on a zone, and I have recorded those, and then I come back, and with similar conditions, those values have changed. I have now something that I can look at from the last time to know that those values have in fact changed. I can verify that we have in fact gotten the performance that we had intended to with our improvements. I can record changes since the last visit in any kind of values. Sometimes when a contractor is at a site, he or she might know that the people on site have monkeyed around with something in the system, and monkeying is a technical term, have changed things in the system but are not entirely truthful. having records of what was there the last time you were there is helpful in understanding how those changes actually are affecting things. We can anticipate future maintenance issues. Sometimes we're going to be able to see changes in solenoid resistance values that might allow us to know that we are going to need to change those on a subsequent visit, for example. And then also gives us an easy way for us to work from the beginning through the end when we're troubleshooting. If we know what we have, then we have an idea of what we can anticipate in certain types of losses through the system as we go. So if we know what we have, then we can anticipate what some of those losses will be as we're working through it. A few years ago, I put a sheet together for our team. This was the Ewing service visit checklist. And this this that I can email it to you, or you can download it from www.ewingeducationservices.com. And but this is something you can create for yourself. You'll notice that it has multiple categories, and I created it using Excel. If you're not really adroit with spreadsheets, you can download templates for it. In my case, I happen to have used a wedding planning template because weddings have a whole lot of categories to them, and it was easy for me to lay this out. Then our marketing people made it look spiffy, as marketing people are quite capable of doing. And so let's just move to the first category. So this is in the upper left-hand corner of the document, and this was initially set up as a troubleshooting document, so some of the statements on here lean in that direction. For example, eliminate the obvious, and that was in this case saying, well, is everything turned on if you're trying to check about water flow? And so the categories here talk about the point of connection. It talks about the meter, the water meter size. It talks about isolation valve size, service line information. Now, it doesn't ask for well information here, but that could be another category that's in place. And I'm going to back up here for a second and just note each of these categories could and should actually have its own page. So if some of the categories that we're talking about look incomplete, we had to sacrifice some items in order to be able to fit it all on one example sheet. So if I were to have a full page on this, I would make sure that I had information on well as being possible. We have backflow prevention type and size. We have a space for pressure regulator, model and size if there is a pressure regulator on the system. And perhaps the system might have a master valve on it. And so here we look at a point of connection in this place, and here right now we're looking at a water meter on the left. And so the water meter is going to be maintained by the water purveyor, that person or company that's supplying the water for that site. On the right-hand side, we see up top the top of a wellhead. And in the bottom right is in this case, it's a well in Washington state, and it's got a unique identification number. Some states keep logs of the wells so that a contractor or anybody in the public, if they know what the unique identifier is, or they know the township range and section, they can get further information on the well, and it's on its initial drilling report and so forth. So this one here, heavily redacted, is in fact the report that went along with the well tag that we just saw. And it tells us that at about 230 feet, that was the point where they first hit their water level, but they didn't go to the trouble of seeing where it had drawdown with a pump. So you know the limitations of all the testing on this particular well to start with, and then you're going to have to get more information on it from the company that installed the well pump in this situation. The next thing I'd be looking at are isolation valves, and these are isolation valves you might see on a typical residential system or light commercial. Most often we see ball valves, either plastic or brass. We also see gate valves. Ball valves will tend to be more positive, and we don't see erosion through them. So sometimes on the underside of the actual gate in a brass gate valve, over time we can get a little erosion and leaking through them. Thing about a gate valve is we can close them slowly, so we won't We won't slam things shut. With a ball valve, they tend to be all the way open or all the way shut. Sometimes it's hard to get a partial closing on them. And then one other thing that's sometimes used is also a globe valve, which will have more of a internals like we would see in a standard water faucet. If we're looking at a larger system, we might look at butterfly valves or larger gate valves that would allow us to be able to open and close those systems, but give us some additional leverage that we might not have with some of the smaller ones. Service lines. What kind of service line do we have? So if we have ductile iron or galvanized, sometimes we can have intensive corrosion. Ductile iron less so, but we'll still get iron oxide problems that we may experience downstream in some other components if the ductile isn't coated. But if you have galvanized service lines in old houses, then sometimes they're going to look like some artery problems that some of us have. You can see that internal corrosion there, and that is so if I have a situation like that, perhaps I will have an inability to get more than a few gallons a minute of flow, where in fact I was able to get tens in the past. So then the service line that we often see instead is copper. Copper's downside is its expense, but it is open and not as prone to corrosion on the inside, so we will see copper lines hold their internal diameter very nicely over long years of service. One other thing that we will see for service lines, especially service lines between the meter and the house, are copper outside diameter tubing such as PEX and Wurzbo. And then we still see some polybutylene tubings, which are they had problems over the course of the last few decades. Those are getting replaced, but they still exist out there. The main thing to remember is these are copper outside diameters, so they will have a thicker inside wall, and they will have a smaller area for the water to flow through than a copper tubing of the same size. And for most of our mainline and lateral piping in this country, we use we'll use Schedule 40 and Class 200 PVC in a lot of our irrigation systems, commercial and residential. Class 200 piping is piping that is a constant working pressure of 200 psi regardless of size. Schedule 40 is tends to be thicker walled, and it's in smaller diameters. So will be stronger if hit by a spade if you're using 3/4 or 1 inch, but both of them will be thoroughly up to the task with most irrigation systems. Another type of piping that we see in the mountain states and in some other areas is high density polyethylene that gets pulled for a lot of lateral piping, though they may use PVC as a main line. In Gulf and larger commercial systems, we're also seeing fused HDPE, high-density polyethylene, being used because of its a fully fused system is less prone to leakage, and also in some cases it's considered to have a lower carbon footprint. But typically, PVC is what we're going to see. The next thing we had on the list was the type of backflow preventer. And so backflow prevention, the main thing that we're looking at here, and homeowners, this is especially important for you to think about, is that we want that if we're putting in an irrigation system, we are setting up a cross connection, that is a potential place where water that is no longer potable may go back into the drinking water system. The atmosphere, the backflow preventer, its purpose is to prevent contaminated water, whether it is a low hazard contaminant. That's something that's going to affect the color, the taste, the flavor of the water. It's more of an aesthetic part of it. It's not going to cause illness, injury, or death, but it is not going to be pleasant. Whereas a high hazard contaminant is something that could potentially cause injury, illness, or even kill someone. So one of the most commonly seen backflow preventers in certain parts of the country is the atmospheric vacuum breaker. And homeowners will see that a lot of times in combination valves where you have a valve in the first part of the device, and then you'll have a float in the second part of the device. And here we see a whole line of those in next to an apartment building in Southern California. The other kind of backflow preventer that is, and this is, I'm sorry, I forgot to mention, this one prevents back siphonage. So if you have a loss of pressure on the mainline side, a fire engine putting a fire out down the street, and it's pumping water out of the mainline pressure drops, then that could cause a loss of pressure on that side and draws water back through the house. An irrigation valve is on, water could potentially be drawn back into the home or potentially even into the water main. Pressure vacuum breaker serves the same purpose. This is designed to handle back siphonage, and it is able to be under constant pressure and protect multiple valves downstream. So while with the atmospheric vacuum breaker, we were seeing that we had to have multiple valves. Each float had to have one valve before it to protect it. This one can protect multiple valves downstream of it. Both of these devices need to be mounted higher than the highest point in the system. And so in the case of the atmospheric vacuum breaker, 6 inches higher than the highest point in the system, pressure vacuum breaker needs to be mounted 12 inches higher. Double check valve. Double check valves are two equally weighted check valves. That means the springs are the same size. And so the notion here is if I have one check valve that fails, the second check valve is there to prevent any backflow coming through the device. It can protect against back siphonage as well as another form of backflow, which is called back pressure. If I have water that's being pumped uphill, then I have a column of water that is going to put a weight back down onto the device, and that is going to be back pressure that is caused by that elevation shift backwards. Now, if I have any kind of fouling in the number one check, the number two check should protect it, but if I have both checks fouled, there is no way to know that that device is not actually providing protection until the next time that the device is tested. It's supposed to be tested annually in most places, but sometimes that doesn't occur. So this is no longer considered an adequate device for protection against high hazard contaminants. In some states, high hazard contaminant is only considered to be the case when there are fertilizers injected or when a pump is in place that could be causing a back pressure situation. And so that is why you'll see in Texas, Louisiana, Oregon, Washington, and some other states, the use of the double check is still prevalent. One other thing to note is that winterizing is a really, really groovy thing. This one was up in Washington as a double check that was a couple of agencies were arguing over. While they were arguing, they had a deep freeze, and the top of that check valve there where the arrow's pointing popped up just like Popeye when he used to squeeze his can of spinach. The last one that we talk about is the reduced pressure principal backflow preventer, or the RP. This guy here is the Mac Daddy of all backflow prevention, aside from the air gap. But this one is what we use when we're trying to protect our irrigation systems in the most thorough way. And what this has is two checks. The number two check is weighted differently than the number one, and it has a relief valve in between. So what we have is a zone of reduced pressure between those two check valves. If we have anything that causes that the pressure coming in to equalize with the pressure that is in the center of the valve, then we're going to see that relief valve open up and try to dump water to ground until the pressure in the center of the device drops down again. So what that allows for is if I have anything that's fouling the number one check, it's going to dribble. So a lot of times you'll see a reduced pressure principal device, or RP. An RP will be dripping or be kind of dribbling consistently. There's something that's probably fouling that device. If I have a fouling of the number two check and back pressure, I will always also see dumping to ground. So that way it's got two things going for it. It's got the two checks, plus it's got an air gap beneath them to give us almost three forms of protection here. It needs to be mounted above grade. It can't be buried like the double check, and it can protect devices that are mounted uphill from it. It can protect devices that are downhill from it, but it just needs to make sure that you have a 12 to 36 inch clearance below that relief valve. One of the things that we use the RP for, or the backflow preventer for, is one of our places where we can measure static pressure. We don't have any kind of a measuring port at the meter, and so what we can do is we can take a measurement at the number 1 test cock. So that would be the very first test cock that's circled here. We do that because if we put, and this is important, if we put a gauge here and we experience, when we're testing our static pressure here, it's going to be the same as the static pressure back at the meter. And if I were to turn on any of the zones downstream, I'm going to experience some loss because of friction loss through the service line and the meter. But all of the losses that I'm reading are happening before that gauge. So a lot of times we'll see somebody take a reading here and they see a drop in pressure. They'll assume that the losses are happening after that double check. It's incorrect. So just remember that every time you're placing a gauge on the system and you're doing your test, you're reading all the losses that are happening before that point. Remember, static reading is when we're taking water while it's at rest, and if we had a dynamic reading, we would be doing it while the water is at motion. Sometimes we have really high pressure when the system is being put in, and so we have a pressure regulator can be put in place, and the pressure regulator can, after the device has had a chance to equalize, maintain a static pressure lower than that is provided by the purveyor. Places like Colorado Springs that have static pressures as high as 190 pounds will routinely put these next to their water meters. Master valve. Some systems will have master valves, and if small residential or commercial systems can have master valves that are exactly the same as the zone valves on the system. If they're all being run in sequence, each valve running individually, there's no reason to try to accommodate any flow larger than the largest one that's there. Sometimes you're going to have when you have larger systems, larger parks, golf courses, that type of thing, you may well have a normally open master valve like this one here, which is basically going to sit as a giant coupling until the controller, through indication from a flow meter, is going to know that, oh, there's a high flow situation somewhere, we're going to shut this down. Usually you have these in place where you have to have quick couplers or other things all with water always available to them, and so that's why you would have one that would be normally open. Most of our valves that we use in our systems are normally closed. That is to say, if I don't have power going to the solenoid on that valve is going to default to the shut position. Controllers. Well, controllers have gone through all kinds of changes and iterations over the years, but one thing that we're always doing with controllers is we are trying to get water to come out at just the right time in just the right way. On this sheet, the way it's laid out, we have two different places for the information. We're starting off with the information on the left-hand side that's simply going to tell us, can we get water flowing? On the right-hand side, more specific information about the controller itself. And here I need to see if I have a complete program. The one thing that's not mentioned here is that it does need to know what time now is. But then we have start times, watering days, zone run times, and then how do we go about running a diagnostic program just so we can see if our zones are running off the controller. And regardless of which kind of controller I'm using, generally I can find some means by which I can run a short diagnostic program where I can run every station sequentially for 1 or 2 minutes. And different controller features that we look at also, are they conventional or are they using two-wire? Two-wire is something that is more and more prevalent, more and more affordable, but our conventional systems are the ones where we have a common wire and then we have a control wire for each of the valves. With two-wire, we have a single two-wire path, and then we will have a decoding device that will be placed next to each valve or or other device that needs to be controlled downstream on the system. Two-wire has the benefit of being much more expandable, much more flexible if I am going to be anticipating changes or expansion of a system. Is it Wi-Fi controlled? Wi-Fi is the new buzz, and we have a lot of the same features that we've always had in smart controllers, but now it is being manipulated in a different way. Different brands are able to tie into our home automation systems. We have all kinds of different phone apps that are available. And when we're looking at that, then we also want to know, is it similar to when we have central control where we have a satellite or remote access? Is it smart control? By that meaning, does it have automatic adjustment that happens either using on-site sensors or some sort of paging surface, some other way of accessing weather stations that are local to that controller? Sensors and different types of sensors, whether it be wind, rain, moisture in the ground, and so forth. What kind of interface does it have? Does it have a dial interface? Does it have buttons? Is it app only? Those are important when you're trying to figure out how is your crew going to work with that controller. And then also, one thing that you might find on larger controllers, more commercial controllers, is does it have multiple pump and master valve terminals? And if so, where do the wires from them go? So if I look at the brand of the controller, then I want to look at see the brand. I want to know the model. I would like to know its station count. What types of features does it have? How many programs does it have? How many start times for each program does it allow me? Does it have a cycle and soak feature that will allow us a station to divide up its runtime for a particular day, just so that way it will not be trying to apply more water than the soil can take in? Does it have seasonal adjust, which would be a seasonal adjust would be where one would manually make the adjustments that a smart controller would try to do on a daily basis? Internal diagnostics, so is it able to check itself out, or do I need to be using a standard voltometer to do the same types of things? What types of sensors does it have? And then the last bit down below is resistance readings that I would take at the controller, so I would know what I have right now. What's the condition of the wiring out to my solenoids, and what's the resistance value of the solenoids I have in the field right now. And it says there that I'm assuming that somewhere between 20 and 60 ohms is my good functioning range for most of the brands that we have out there now. If you have a schedule that's designed and put in place, lamination is a really cheap and awesome thing to do. Lamination allows us to refer to it later on. Fortunately, somebody had a copy of this in their laptop and they made another one, but you know. We have different types of sensors. In this case, we're looking at a weather sensor up above that's taking into account rain. It's taking into account solar radiation, relative humidity, temperature, and so forth. We have a flow sensor in the upper right, moisture sensor there in the green, wind sensor, and so forth. So these are all different types of add-ons that can modify a standard controller, and sometimes we have we'll have a controller that is subscription operated, but we'll still have a rain switch in case it rains locally and it was something that the weather hadn't predicted. Here's a resistance reading being taken at the controller, and we have a good value here. And here we have the pump master valve terminals. If we have multiples, usually the one on the left will energize every time a station energizes. So that way the master valve would always turn on when a station valve would turn on. The second master valve terminal is often programmable, so that way if I had spray and drip zones that could work just fine with standard municipal pressure, I wouldn't bother turning the pump on, but for rotors that might need more pressure, I would energize that terminal. And then the next thing I'd be looking at are my rotor and spray zones. And so what I want to do with these is I want to run through each of my zones, and then I'm just looking for different types of things that are happening. Now, the first thing that I have here is that I want to talk about, does it have a weak stream or a pattern? Does it have misting, meaning it has too much pressure? Does it have incomplete edge coverage, which is either, if it's rotors, it's not adjusted properly. If it's with sprays, then perhaps I have the wrong arc, or the head is positioned too far away from the edge. I like to see how many minutes do I have to run off. I like to see what my pressures are in each zone at the first and last head, so that I don't have more than a 10% difference in pressure between the two. Do I have have we trimmed around the heads? Have we done radius adjust? Are the heads level and plumb? Are the heads to grade? Are their wiper seals intact? We see leakage around there. Are the body and the caps intact? And then we have some different kinds of landscape clues that we might look for, like erosion, a flattened turf funnel where you have a rotor that is below grade and has kind of burrowed itself out, kind of like an inverted funnel. Donuts that we will see that look like crop circles because of low pressure. Low head drainage, if it's occasional, it's probably just we have the low head itself and we're draining the excess water out of the laterals. Or if it's consistent, that might indicate that you have a weeping valve. We have standing water. When you step on the turf, does it spring back, meaning it's nicely irrigated but not overly irrigated? Are we seeing any kind of turf stress? And remember, if you're seeing stress, then you might also be seeing something that has nothing to do with irrigation, might be a biotic or abiotic disorder that your agronomics friends might want to take a peek at. And then we look and see if do we have a shrub and tree blockage that is that's causing problems with irrigation coverage. Shrub and tree dieback, which means that we may be overwatering or underwatering, but a lot of times overwatering. Are we getting any kind of overspray on hardscape? Are we doing that with walls? What kind of pest pressure? Mosquitoes that might be breeding in the turf itself, fungal disorders, and the like. So here we see fixed sprays that are, even though we don't have a gauge on them, we can tell just by their pulsing pattern here that they're under pressured. This one here, these are fixed sprays that are over pressured and misting. And so our fixed sprays, generally we want to see them around 30 psi. And so here's a T that we can put on top of a riser, put the nozzle back in place, and so that way we can measure pressure at flow, so we have the full flow of the zone while we're measuring the pressure on it. So when you have things that are broken, suffer from mower blight or other abuse, we want to make sure that we take note of those so those can get repaired urgently. So this is a zone that's working nicely. Here's a zone that's suffering from, I don't even know if it's benign neglect, just neglect. So then when we look at rotors, we have different types. These are multi-stream, multi-trajectory rotors, and that's like the Toro Precision Rotary, Rainbird Rotary, the MP Rotator, etc. So those are rotors that are putting multiple streams out. They cover a longer distance than fixed sprays can. Fixed sprays are covering up to around 15 feet. Some go slightly longer, but they're trying to cover the entire pattern at the same time. These are able to cover a longer range, and they are usually applying water at a significantly lower rate than fixed sprays. So fixed sprays, you see 1.5, 1 3/4 inches an hour. These are looking more in the neighborhood of 0.4 to 0.6 inches an hour. Single stream rotors. Notice these guys have that nice fallout of water underneath their arcing streams. We want to see that fallout mist. That is why they are so pressure dependent. So pressure is essential for these. There's a rotor that's out at the Seahawks training facility up in Renton, Washington. And here we're measuring between heads. If we're measuring between heads, we like to use tapes, not wheels. Tapes are more accurate, so you want to just verify that your head spacing is to specification. And we're measuring pressure using a pitot tube and gauge. And for us in the landscape world, the pitot tube is really the only tool that can accurately tell us what we've got at the head. If I have too low a pressure to know what the flow is, because that pressure is not listed on the manufacturer's chart, then I can take some 4-inch drain pipe and an elbow and just press them together, and I can create a flow tube, create a seal around it, and then time it with a 5-gallon bucket and see how much flow I'm getting out of that particular rotor at the pressure it has right there. And then here we see some different problems in the field. We've got a rotor that's popped up out of the dirt, and we've got some edge coverage issues over here on the right. Sometimes you just have things lying down on the job. And this one, you actually had to peel the turf back in order to get this rotor to stand up. So these are maintenance issues that could be handled by a technician on a regular basis if they just would bother to turn the zones on while they're there. Now, sometimes you're going to be looking for different issues. They won't show up at the time of year you're there. So this is this is in spring, and everything looks great because winter has already filled up the soil profile. So everything looks sweet and wonderful. But you get to later on in the season, and everything really shows its true colors. The irony is that all of the zones work very well, but this one, during the time it irrigates, suffers a significant pressure drop early in the morning. And the only way to know that was to do an audit, find out that this zone was suffering at a different time. We had to put a data logger on it for 24 hours to see when the pressures were dropping. So you may not see everything the first time you're looking. Drip, we like to clean filters. We like to clean pressure regulators. So now we always like to have filters on municipal drip, and we'll see why in a moment. Pressure regulators, sometimes they weep. We have to replace those if that's the case. Flush lines, confirm operation, make sure that everything is coming out as we can. Sometimes we're not going to be able to see the drip itself, so we'd like to soil probe in the root zones to see how well that's working. Line breaks should make themselves pretty manifest if you run the zone long enough, and so we want to look for those. Any missing components that dogs may have grabbed. Dogs like micro sprays quite a bit. They're entertaining for them. And then we have different kinds of landscape clues like ponding, washout, dieback and death. And remember, dieback and death with drip a lot of times is happening because we're overwatering, and then water below the root zone. And so some things are inexplicable. In this particular picture, the most important component is the screwdriver. This technician jammed through the pump switch to keep the pump from cycling with all the shenanigans that they put in place. Here we see some atmospheric vacuum breaker, combination valves, filter, and pressure regulator. And this is at the Gold Medal Garden in the Rose Garden in Portland. This is a compact filter that was installed about a year ago, and the folks there were asked to clean it every 6 months, but they did not. And it has uncoated ductile iron serving that location. So there are a lot of iron oxides and iron-loving slime, bacterial slime, developed in it. And fortunately, it was protecting really large orifice emitters, so none of the stuff that extruded through it would bridge. But it just goes to show you that it doesn't take much to load up a filter. If it doesn't necessarily have to be solid debris, it can be debris that actually breeds on the filter itself. And there's a clean filter and a happy rosarian in the background. And so if you have zones like this or this, a lot of times you're not even going to be able to figure out what you have irrigating in there. You're probably going to have to run the zone, look at the water meter itself, and determine what kind of gallons per minute that zone is doing. So that way you can come to a figure that you can use for scheduling. Sometimes with a zone like this, where you're going to have more individual emitters, you're going to be able to determine for each plant if you can expose them under the mulch. But for something like this, I'm going to have to guess at an application rate based on the flow and the overall area of the plant material. This is subsurface drip and turf. And the large rectangle in the background, that is done with multi-stream, multi-trajectory nozzles. That subsurface drip on the oddly shaped portion toward us. And you'll notice that the edge, right toward all the rock, has some spots that are drying out. There needs to be more water put along that edge to make up for the extra evaporation that happens because of that hot surface. This is in Phoenix, so that metal edge is getting extra hot. And a lot of times this is going to be the best that you're ever going to see with the first time you're going to, and the last time that you're going to see the thorough layout of a drip system. So knowing what you have to start with is really important to document when you can. And drip problems can, this was an initial layout. Most of what it used to feed has died off for whatever reason. So this bears reconsideration. Ponding, it can be another issue. And if we start seeing this, and you're having either some sort of break in the line, or it could just be that the precipitation rate or the application rate for that drip zone is too high. Remember, if we have 0.9 gallon per hour emitters in line source drip, that is the emitters that are extruded into the line at the manufacturer, we lay them out like a grid. So if we have 12 by 12 spacing on that grid and 0.9 gallons per hour, we're putting water out at 1.44 inches an hour. That is the same kind of rate as fixed sprays. So just because it's drip doesn't necessarily mean we're applying water slowly. So we have to as best we can, figure out what kind of flows we have going into what areas so that we're not overwatering. We want to locate our valves, and if we can do that, then we can map things out. So we want to have as much information about our valves as we can. Try to do all these things that, if we're looking here, that we can create some maps. This is the only thing that's right about this particular map is that it happens to be laminated. A better map would be something like this that was done with Microsoft Paint. This is showing which areas get served by which valve, but ultimately a map like this that is done, this is one of the parks in Portland Parks, and the technician there updates his drawings regularly to show any kind of modifications or changes. But troubleshooting in this park is really simple. And if you use 2-wire or considering it, you need to start thinking about drawings this detailed. This is a perfect valve box. These are more realistic, and they come in all shapes and sizes. And the main thing is that we want to have them as drained and accessible as we can, but that's one of those things that requires ongoing maintenance as we go. You can fit a lot of valves into a valve box, but a lot of times you have to cut them all out if you try to get too greedy. So 1 or 2, easily accessible, is preferable. And when I'm testing, remember internal and external bleed. How are those valves working that I have there now? If internal bleed works just great, that's wonderful. If it works better when I turn on the external bleed after I've turned on the valve at the controller, I may want to examine that valve and then look about its internal porting. Don't save money on wire splices. This is at a federal installation. Yes, it's conventional wiring. It's working just great with the wires just twisted together. But if it were 2-wire, it would fail within a few weeks to a month. So we want to be using the splices that are recommended by the manufacturer in each application. Please look at the manufacturer's specifications for what they recommend. The last section is entirely focused around water use and how much that zone is capable of putting down in a certain period of time, and then how would you relate that to the water bill that you get from your water agency. And so if we're looking here, the thing is, it talks about what's the zone's precipitation rate, and that is information that I can get by measuring the pressures and measuring the flows and the areas that that's going into. Or I can also look at the configuration of the heads and look at the manufacturer's catalogs to get relatively close. What's my runtime in minutes that we have scheduled? Then I want to find out what's my how many inches am I applying per cycle. The next thing goes down to how many cycles am I doing per week, and that's so that's if I have 3 different days that I'm running. Maybe I have two cycles in a day. If I'm running 3 days, that would be 6 cycles per week from that example. Then I want to know how many inches per week am I applying, And then I can figure out my weekly billing units knowing all of that. If you're in the East, a lot of times you're billing in 1,000 gallon units. A lot of times in the West, we're billing in units of 100 cubic feet or 748 gallons. And to figure out about those calculations, if you can, the certifications through the Irrigation Association technician, landscape irrigation auditor are very useful. Also through the NALP, Landscape Industry Certified Technician, and then QL and CLCA Water Manager program as well. And so if you were looking at some place like the City of Redlands, here you have their bill and it's laid out, and so you have your water rates for as you have for each meter size, plus your cost per unit above and beyond that. And each of your municipalities will offer that up in a different fashion. So you can create your own list to work through an inventory just to figure out what you're comfortable with to start, and then build upon it as you go. This was simply an experiment that we tried and we liked, and we hope it is something that you might be able to find useful in the future.
That was great. You know, another thing that's important, I think, is for the homeowner or the property manager, because this gave a pretty good in-depth view of what somebody should do. A lot of times people from property management companies have no clue to what you just presented, and that's okay, but I think it's important that they bone up on some of these subjects, and they can go to the Irrigation Association, and they have plenty of books that you can purchase that show all of this stuff, and it's not that difficult. You don't have to get the most extensive hydrology documentations to do that, but I think it's important. Another thing, you mentioned the water meter and checking. How many homeowners and even apartment owners and things like that, how much do you think they can read the water meter?
I think very few know how to, but it's amazingly simple once you try.
Right. And those are things that are, I think, super important, that people who own a home and having the expense of paying for water, or property management people, because I'm not saying landscape people try to take advantage of other people, but you need to know when somebody tells you what's wrong with something, like, hey, you got a leak from the valve, or the valve's not working. There's not that many things that can cause the valve to go bad. There's a few things. If it could be the diaphragm's got some dirt underneath, solenoid could be bad, you could have a crack in it. Those are things that people understand if you take the time, or they take the time to read it themselves. I think having a little bit of knowledge is better than not having any knowledge at all. And you can speak to the professional or the non-professional mow and blow guy to do your work. So I suggest everybody go to the Irrigation Association, which is www.irrigationassociation.com, and take a look at all the books they have. And they're reasonable. And if you don't want to go to the library but get something more extensive, I think it's a good way to do it. It's irrigation.org. Yes. Did I say com?
Yeah.
Oh, I'm sorry. .org. Or it could be .net. There's so many of these things. It's like you go to the store and you give a credit card. Now, what's your PIN number? Well, you got X amount of credit cards, and what PIN did I? Or you go to the store. What's your phone number? Well, I got several phones: my cell phone, my wife's phone, our home phone. What do they have on the reg? I have no clue. You got to remember all that stuff. Maybe we should just get like that commercial where you have a barcode in your head and they just scan your head across the stuff. Anyway, Tom, you did an excellent presentation, and I hope everybody got a whole lot out of it. To get your credits, the code that you need to know is called W as in William, Z as in Zone, -4. So like WZ, like in water zone, -4. And you just simply send that information of what that you listened to the irrigation.org, and that'll show the people that you did listen or watch, and hopefully you watched. I know everybody was excited you were coming aboard, and we want to do something great, so we had everybody chip in to give you something, and we collected all the cash we could. It's $1.16, but no, just kidding. We wanted to give you this present for being on the show and giving your time coming down from Portland to do it.
Well, thank you.
It's a wireless speaker and FM radio.
Outstanding.
So you can listen to the water on the thing. So we certainly appreciate it, and I hope everybody had a good time listening to the show. Remember, everybody, join us every Thursday night. You can see a repeat of this show, for those of you who didn't catch the whole presentation, on the following Tuesday at 7 o'clock. Or you can download it on the website. So appreciate everybody coming. Tom, again, thank you. Thank you, Ewing. Go to your Ewing stores and buy stuff. They're a great store, great information. And remember, the most important thing to do each week is to think blue. Good night, everybody. Have a good one.